Welcome to the Illinois EPA Office of Energy Public Water Infrastructure Energy Efficiency Program's Fall Webinar Series, even though it doesn't feel like fall so much today with the snow. This is the fourth webinar in our series, and we're happy to have you here with us. So please take a moment, as you have been. If you haven't yet, say hi in the chat and let us know where you're coming from today. It's always great to see everybody in the chat this morning. And my name's Cassie Carroll. I work with SCADA and the Smart Energy Design Assistance Center, and I work with my colleague Sean Maurer, who's our technical director here at CDAC, to deliver this program to you all. Before we get rolling, of course, I want to go through some Zoom housekeeping items before we get rolling. So please feel free, as you've been using, use the chat throughout the day. If you have different ideas to share, if you have a comment, want to say hi, or even want to ask a question, feel free to use the chat. Questions can also be answered in the Q&A box throughout the presentation. We'll have time for some questions and discussion at the end of our session. This event is being recorded, and the recording and the slides will be shared later today with you. So we'll email those out as soon as the recording is available live on YouTube. And we also do offer CEUs and professional development hour certificates for all of our events. So once we get that CEU number for this course, we will send that out to you as soon as it is available. So thanks as always for your patience with getting those course numbers. I know the Bureau of Water works really hard to get those training courses entered, but we will send them out as soon as they are available. So today's webinar is focused on using automation to increase energy efficiency at water treatment systems. So we know automation can save a lot of money and energy for water treatment plants, but sometimes the cost of fully automated treatment system either isn't feasible or is just really expensive for smaller communities. So this session will look at how to select key processes to automate and what are the bare minimums for effective control and energy savings without breaking the bank. So we have some great speakers today that will be sharing their knowledge with you. So Jimmy Jackson, he's Alter Market Sales and Product Support at Ressler Associates Incorporated. And Sean Maurer, our technical director, will also be speaking today from CDAC. Just wanted to give you a heads up as well. I will put this in the chat, but we have another webinar next Tuesday, if you're able to join us at 11 a.m. Focused on preparing your energy efficiency projects for funding applications. And actually, the director of the EPA Office of Energy, Chad Cruz, and Amy Roderick, who is the Grants Program Manager at the Illinois EPA Office of Energy, will be joining us. We'll also hear from Quantified Ventures about SRF, or state revolving loan funding. And then we will also have Andrea Reif from the Ameren Illinois Energy Efficiency Program, Marcello Pibiri from the ComEd Energy Efficiency Program. They will all be joining us on this webinar. So I'll put the link in the chat here shortly. Please feel free to register for next Tuesday's webinar session as well. Okay, so now just before we get started, I want to tell you about the two organizations that run the Public Water Infrastructure Program. So a little bit about CDAC. We are an applied research program at the University of Illinois with a goal of reducing the energy footprint of Illinois and beyond. So we do a lot of work to really just help public sector customers and facilities figure out ways to reduce energy, reduce costs, and we provide support along the way. We are one of two partners that works in the Public Water Infrastructure Program. And we also work with the Illinois Sustainable Technology Center. So I'd like to invite Bill Oxel here to speak a little about the ISTC, their mission, and what they do. So Bill, take it away. And I know I just promoted him to a panelist really quickly, so he's probably figuring out how to unmute. It's all good. Hey, Bill.
I did. Thanks, Cassie. Because I was trying to figure out, I had you guys on a reduced thing because I was frantically trying to pull up the ISTC website to, give a nice how we're at the crossroads of technology, sustainability, etc. But rather than the old hat one, I'll just say, basically, our purpose is to try to help businesses, citizens, everybody in the state of Illinois with their energy efficiency and sustainability projects. We have several programs. You can pop on the website and check it out, Illinois Sustainable Technology Center, of which I do manage our branch of the public water infrastructure, and grateful to be partnered with CDAC, and very thankful for you guys at CDAC for putting on this webinar series. Great education. I've learned an awful lot. Oh, see there. Thank you, Cassie. You have our little slide up there to encourage and assist citizens, businesses, etc. But basically, we're very happy to partner with CDAC on this program for the public water infrastructure, and especially ahead of next week's, where you're going to learn all about the money. I would say make sure you sign up. Cassie has a great goal of getting us not only people signed up, but for everybody out there to get their information, their billing, their process flow to us. And you will definitely want to do that, because when it comes to the NOFO, if you haven't participated, trying to get money will be a no-no. And it's like the lottery. You got to be in it to win it. So please sign up, get your information to us. And we don't care who's driving the bus, whether it's CDAC or ISTC. We just care that you guys participate, and we'd love to bring efficiency and resiliency to you. So hopefully that wasn't too long-winded. Thank you, Cassie.
Thanks, Bill. And what Bill was referring to is the Office of Energy actually offers a notice of funding opportunity for wastewater systems. So you'll learn about that more next week. But thanks, Bill. Appreciate it. And now I'll turn it over to my colleague, Sean Maurer, who's our technical director, to talk a little bit more about the program. Sean?
Well, thank you, Cassie. So a little bit about the program. It's a partnership with the Illinois Energy Office to provide no-cost energy assessments and technical assistance for potable water and wastewater treatment facilities. So we'll come out to your facility, provide a no-cost assessment. We'll walk through, look for energy savings opportunities. We'll look at projects you want to implement in your facility and see what kind of energy and efficiency impacts those will have. We'll go back to our offices once we've completed that assessment, figure out what the potential costs of those measures are, what the paybacks might be, and we'll dig into those potential incentives and funding opportunities and let you know where the money's at to help you apply for those funds. And we also offer continuing education events such as this one. You can apply for one of our energy assessments at our website, smartenergy.illinois.edu/water. You can also review our previous webinars there as well. So why might you want to complete an energy assessment? If you've got an older facility or you haven't had a previous assessment, we can identify missed opportunities. We can plan for capital improvements. We can work with you to figure out ideas that you have, how to get those implemented at your facility. We can uncover the wide variety of potential savings opportunities. And again, that third-party support for your ideas. We want to help you advance your facility the way you want as well. What if you have a new facility? It's brand new or it was recently renovated. It's got all new stuff in it. Well, there's always more ways to improve. There's always new technologies in development out there. So we can help dig through those and see, is there anything that got left on the table? Was there anything budgeted out of the project that didn't get implemented? So we can always help you stay on the forefront of new technologies and what's going on with water treatment. And again, we're always available to help identify opportunities for funding and help direct you towards those resources that can help push these projects forward. So to apply for an energy assessment, go to our website, smartenergy.illinois.edu/water, and fill out the pre-application form there. Just some basic contact information. Let us know that you're interested and you're willing to share the information we need to conduct an assessment. Then we'll be in touch with you soon afterwards to do some data collection. We'll have a more in-depth application form. We'll walk through the questions with you over the phone, so it's as painless as possible. Just gathering information like how many pumps do you have? What horsepower are they? How much flow do you have going through your facility? We'll also work with you for water plants. We want to gather 2 years of your utility bills. For those of you on ComEd and Ameren service territories, all we need is an account number and we can look up the amount of data that we need. If you're in a co-op area, then we'll have to have you supply those 2 years of historic bills to us. And then we'll also need your monthly operating reports so we know what throughput you've had through your facility. How much water have you treated? And we'll use that to develop an initial benchmark of your facility, and we'll bring that out to the site visit, let you know where you stand relative to the other facilities we've looked at. And we're here to assist. So, wherever we can help pull that information for you, we will do so. I know on the wastewater side, there's a NPDES database that we can pull your operating reports from. It's not really set up on the water side yet, so we're still relying on you to provide those reports and flow information. But if anything ever gets set up, then we'll do that. So we try to make this process as painless as possible, and then we set up the site visit. Once that site visit is scheduled, we're out there for a couple of hours. We're taking a lot of pictures of your equipment, the facility, and identifying what savings opportunities are there. Once we return from that site visit, within a week, we'll have a short list of potential measures that we're looking at that we'll provide to you. We can customize that list once you've reviewed it. Remove things you've already looked at and determined aren't cost effective. You don't want to bother with putting in the report. If there's something we left out of the report that you want us to include, let us know. We'll add that to the short list and make sure that that report is tuned to what you want to see. As far as today's presentation, we're going over automation for time management at water facilities. This is going to focus on potable water facilities. I noticed we had a few wastewater operators. A lot of this kind of crosses over a bit. So feel free to stick around and provide your input where you can. Jimmy's got some background in wastewater as well. So you won't feel left out in this presentation, I don't think. Things we're going to cover real quick, identifying the benefits of automation for efficiency and productivity. We're going to try to touch on ways automation can help save time. So we know operators at a lot of communities wear multiple hats. Not only are you operating the water and possibly the wastewater facility, you're also out filling potholes in the road, cutting tree branches. You wear a lot of hats in your community. We're going to investigate automation strategies for some common treatment processes in water plants. Then we're going to look at opportunities for using automation on controls you already have in place and how to take advantage of those to their maximum benefit. And then we'll look at some labor savings potential of those common automation strategies and make sure you understand if you're going to include automation, what benefits you're going to have outside and beyond just the energy savings opportunities. So with that, I'm going to turn it over to Jimmy Jackson from Wrestler and Associates. He's been with Wrestler for about 4.5 years with plant level sales and support. Previously, he was at the Northeast Public Sewer District in Fenton, Missouri for 20 years. He's got a Class A wastewater license and a Class D water operator's license. So he's got some significant experience that he'll be sharing with you today. And as we're going through the presentation, if you do have questions, feel free to enter those in that Q&A window and we'll answer them as we go along. So Jimmy, I'll turn it over to you.
All right. Thank you, Sean. I appreciate it. Like Sean said, that I am aftermarket sales and product support at Wrestler and Associates. My background is wastewater, so I will have quite a bit of discussion about wastewater as we go through here. If possible, if anybody has any questions, I'm more than happy to answer those or speak further down the road. But as we move forward here, let me see if I can get my screen to pop up the next slide there. Apologize. So right now on the VFDs are now widespread application for the pumping systems. And you always have to make sure that you have the proper motors to use VFDs on. You can't just throw a VFD on anything. You got to make sure your motor is more efficient. Sometimes you may have to end up upgrading the motor and make sure that your pump can handle that type of application. It says 50 hertz equates to about 83% speed. So power reduction is decent amount. What you want to do is a lot of these things need to start up at a decent 100%. And then you can back them back down. We've done that with blowers in the past and save quite a bit of money over time. A lot of times you don't think that it's going to be that big of a savings because you're like, well, you're only turning it down, 5%, 10%. But in doing so, after that initial ramp up, the amperage, you can turn it back down, the hertz is lower, and you can save a lot of money over time as you're running that. So that's very helpful in a lot of different situations. On the next slide here, it shows the descent application, a good control through operating range, and the pour application. You need to make sure that the curve is going to meet the needs. You can't have an extremely high head and then turn it down, because you still have to do the work on those systems. So there's certain applications where it's not effective, and you have to try to look and try to mitigate those situations. Here. Says many plants use ion exchange or sand filtration. This requires the backwash, typically manually controlled. Backwash can trigger differential pressure or TSS breakthrough. The backwash can stop based on TSS or conductivity measurement. The temperature affects density and affects the backwash rates. So if you have to manually do this all the time, first of all, it takes time out of your day to do so. And then also you have to make sure that you can only do it while somebody's there. If you can set this up in an automated system on a SCADA system and utilize some instrumentation to monitor the backwash itself, you can do this a lot more effectively. And you can do it to the point where you don't have to over backwash or under backwash. You can set this up to, you know, that the parameters are going to be where you need to set them to be most efficient and time saving. And my background is not in water necessarily. I know that you guys spend a lot of time, you know, checking your filters and things like that, but to have the online process instruments to, you know, hook to your SCADA system to run these things is very efficient. And Sean, you may have more information on that, on how to, you know, mitigate those items.
Yeah.
On that.
I actually wanted to go back. We had a poll here that we skipped right over. I was trying to click on it and we advanced the slides before I could.
Sorry.
It's all right. But going back to the VFD systems before we jump into the poll, just looking at the applications here, one of the things you want to be paying attention to, if you have access to it in your design documents, you should have an approximate system curve that the pump was designed for, with the pump curve laid over top. It lets you know what your design point is. One of the things you want to look at that design point and the system and pump curves is they should be, you know, kind of a near perpendicular crossing point there for you to have effective control. If the curves are both relatively flat, even if you do have a low head situation where a VFD might be applicable, you're going to have difficulty controlling it, because a small change in head pressure is going to give you a large change in flow rate. It's going to be hard to control to that control parameter of flow. So just something to touch on before we jump into the poll question here. I want to launch that, make sure that everyone's caught on to some of the talking points here, but which of the below does not indicate a VFD is going to be a good application? Lower static head pressure, significant variation from the design point, flat system and pump curves, or longer run times. And then we did have a question coming into the chat. Would a motor over 10 horsepower that runs over 2,000 hours a year be a good candidate for VFDs? Jimmy, you want to take a stab at it?
Sorry, go ahead and repeat that.
Would a motor over 10 horsepower that runs over 2,000 hours a year be a good candidate for VFDs?
I think it would be a good candidate depending on what the load is, but if it's going to run continuously, a lot of times you only need all that power at original startup. So once you get the pump running and the fluid is moving and you get rid of that original static from turning it on, I think that's always a great item to turn it down. Even just a little bit over time creates major savings.
Mm-hmm. Yeah, usually when CDACs do an analysis, when we get down to 5 horsepower, 7.5 horsepower, those tend to have longer paybacks, even if they run a significant part of the year. But once you get to about 10, 20 horsepower, at about 2,000 hours a year or so of on-off cycling, those tend to have decent paybacks, getting close to 10 years or less when a VFD is applied to them, provided that you've got a good system and pump curve alignment.
And depending on how many you have, you know,
Mm-hmm.
One may not be a great payback, but if you have multiples doing that, that could be something else. All that little bit adds up.
So our poll results here, looks like most people caught on, especially since I went over it right before the poll question, but flat system and pump curves are not going to indicate a VFD is a good application. All those others, if you got lower static head, you're going to have wider turn down capability. If you've got significant variation in flow from your design point, that's the optimal time to have a VFD. Longer run times are also going to improve the payback period for a VFD. So looks like most people caught on to that. So then moving back to filtration automation, again, the key thing here that we're saving for potable water plants is that shortening that backwash cycle. We go to a lot of plants that it's either manually triggered or automatically triggered that backwash cycle based on differential pressure across the filter or the ion exchange system. Whatever you're using to filter that water out of the system, that backwash is usually triggered by differential pressure across the filters, either manually noted by the operator or automatically controlled by a SCADA system. But what usually isn't controlled is the duration of that backwash. It's usually an industry standard, run it for 15 minutes or however long they recommend to backwash a system, get adequate lift and separation of the sediments in that filtration system so that the sand is cleaned out and ready for the next filtration cycle. And then you've got to run it a bit longer to resettle that material, get it re-stratified so you're not going to have breakthrough for that filtration system. But something that affects backwash is the density of the water. So the colder the water is, the more dense it's going to be, the less water you actually need to backwash a system and break up materials out of the sand bed. So that's something that needs to be accounted for in a control system. And also that duration doesn't necessarily have to be the same every time the filter requires backwash. We've seen a lot of the automation now is using either total suspended solid sensor or a conductivity meter to detect once that backwash has flushed out all the materials and now you're getting clean water out of the backwash again, then it cuts that backwash off instead of letting it run a fixed time cycle. For a lot of water plants we know that we've been out to, that water is coming from the distribution network. They've pumped it out to the tower and then they changed some valves on the filtration system and it flows back through the plant from the tower. So you're using finished water product to backwash your filtration system that now you've got to resupply it back into the system. So there's a big energy penalty there for backwash, especially if you're doing more than you need. So this, a couple of additional sensors on the system and a little bit more automation isn't incredibly expensive for these systems, especially if you've already got differential pressure control tied to a SCADA system. It's a little bit more expensive if you're doing all this manually. But there's a significant payback and a significant regain of your finished water. You're not losing as much in the process. Jimmy?
So with the advanced filtration automation, you can use the PLC controls to maintain the backwash flow through the valve position or the pump VFD speed at a lower rate during air scour, then increase the standard rates during the restratification settling phase.
Yeah, so what we're looking at here is pulsed air in your backwash system, incorporating air bubbling into that backwash cycle. And this can also, again, is significantly minimize that wash water. Instead of just flushing backwater through the system at about 15 gallons per minute per square foot of filter area, you can reduce that down to 3 to 5 gallons per minute per square foot by incorporating 2 to 3 CFM per square foot of air. Again, that air is going to help break up materials in the filter bed instead of just using the volume of water and the velocity of water to do that. And this has been growing across the wastewater industry. There's retrofits for existing filtration systems or brand new filtration systems that can incorporate this kind of pulsed air technology. But again, you're reducing how much of that finished water you're using as your backwash water. So you're reducing how much you have to repump back into your distribution network. And you have some significant energy savings there on the pumping side, and then cost savings on that finished water production. And we do have another poll here, so we'll launch that. Which is the most effective backwash control option? Manually timed backwash operation. Differential pressure triggers the backwash, but it's a timed cycle. Differential pressure triggers the backwash, and then the duration is controlled by a sensor. Or you're manually triggering that backwash, and the duration is controlled by a sensor. Give that a few seconds. I haven't seen any additional questions come in. If you do have questions about any of the technologies we talk about here or the impacts that they're going to have, please throw that into the Q&A. We'll be happy to address it. And a lot of this filtration backwash technology also applies to wastewater plants. We're seeing a lot of plants moving to cloth media filtration, but managing that backwash cycle and reducing how much backwash water you're moving through that wastewater system is some significant energy savings for wastewater as well. Okay, so we've got most of our responses in here. It looks like most people caught on. Yep, you want to have automated on the front end that triggers the backwash and on the back end that shortens the duration cycle. So nice job, everybody. I'll turn it back over to Jimmy to talk about distribution control.
So when the demand drops, pressure tends to increase and increase water leaks in the network. So one of the things about this too is that if your infrastructure is not, good quality, having these items being leaked out is obviously a big waste. When you've already treated water and you're sending it somewhere, and now that you're losing it, that's energy savings that if you had it stay in your system, that's good. So you obviously want your manage your pressures so that you don't have the water leaking out, and you can easily do this with your VFDs on your pumps. And it's not feasible to kick them on and off all the time. A pump that runs continuously doesn't have the hammer, and also it can keep up with the proper pressures in your system. I'm sure all you water guys understand that completely, especially in the wintertime when the ground's freezing and everything's heaving. You don't want those, you don't want that water hammer, you don't want anything bursting on you. Nobody likes the water leaks. And with the pressure management strategies, the method is the fixed outlet pressure control, application using small water pipe networks. It's not expensive. It's unable to adapt to the pressure variations during the peak and on-off demands, and it's simple. Sean, you want to go through a couple more of these as well?
Yeah.
Go back and forth.
Usually for smaller systems, you're going to see kind of that fixed outlet pressure control. It's one of the lowest cost options. You just have a PRV out in the network that your upstream pressure is reduced for the downstream section of the piping with the goal of maintaining relatively uniform pressure across the network, but it's not going to react to demand changes in the system. Things that can react a little bit better to that, you can start doing time modulated pressure control, where you put a little bit of automation on there with some automated valving in your distribution network, where you kind of know what your diurnal loads are in the system. You've got some historic trends in your SCADA system or whatever. You can see when flow demand is higher, when it's lower. So you can kind of program in a time cycle. It's not going to react to odd events. Say, maybe you've got a stadium and a bunch of people come in for an event. There's an increased water demand there on your network. Special events like that, it's not going to react to. It's going to react mainly to that programmed regular pattern that happens. So it's a little bit more expensive to implement. It gives you a little bit better control, but it's not going to react dynamically to your system. It's going to react based on what your pre-programmed time settings are. Flow modulated pressure control. Now you start getting into a little bit more expensive. You've got more sensors out in the network. You've got more automated valving and pressure control systems. So it's very complex, but it's very adaptive, more so than your time modulated systems. It's going to react more to your flow side requirements. And then we get into closed loop pressure control. Again, a little bit more expensive. It's looking at you want to enclose a certain part of your distribution network, and it looks at that control zone and gives you fine control over that particular area of your distribution network. And you would set up multiple ones of these in your distribution system. Parameterless pressure controller. Now you're getting into something that's a little bit more adaptive. It's going to be more reactive in your system. The controller is kind of easy to set up. It's just a PLC controls reacting to pressure sensors out in your distribution network. You've got a sensor set up in the kind of the critical zone for each of your management areas. And then the optimization approach, again, it's a kind of a combination of simpler controls, programming logic, maybe you're going to use a historian and it's a little bit of AI to do some predictive modeling. It's going to give you a lot more reactivity, but it takes a little bit more skill to implement that kind of pressure strategy. But the goal is to have, individual zones of your distribution network broken up into pressure control zones or district management areas, as they're called in some situations. And you're trying to maintain the minimum pressure that you need to satisfy your requirements. So you're minimizing how much pumping you have to do back at the plant. That's going to give you your big energy savings. It's going to minimize how much leakage is coming out of existing leaks in the system. By not having large pressure swings and rapid changes in pressure, you're not going to create new leaks by pipe vibration, expansion, contraction, things like that, that exacerbate leakage over time in a distribution network. And that's where big savings come from for these. So, municipalities that have implemented this kind of work have reduced water losses by about 30% or so for well-managed district systems. But it's particularly useful for areas with significant topographic variation. But that's not the only application. For larger distribution networks that have varying demands in different zones, pressure can swing from zone to zone of that control area. So these management systems can help redirect flow where it's needed, can help maintain that pressure more evenly across the whole system, and manage that water demand so that it has less impact on the operations at the plant itself, and tries to even things out. But what's really key to all of these is identifying what that critical point in your system is. Do you have a low point in the system that always has exceptionally high pressure? Do you have a high point that always has really low pressure and you're trying to keep that pressure high enough to prevent contamination issues? So it's identifying those key areas that you need to monitor, control, that's going to make these effective. So it takes some upfront resources to build these networks out, but the long-term benefits are significant energy savings and longevity of your distribution network.
The distribution network leakage monitoring. So you use the client smart meters to track the water per site. So this way you can see how much water is going through, each sampling point to make sure you're not losing anything anywhere. You can subtract the effluent from the plant water and then the total non-revenue water, subtract the off-verified NRW, so the fire, the irrigation, etc. Then the total volume of leakage, sub-meters and pipe network can help speed locating leaks. So local governments can reduce energy use at water and wastewater facilities through the measures such as, conservation, water loss prevention, stormwater reduction, and sewer system repairs to prevent groundwater infiltration. The measures to reduce water consumption, water loss, and wastewater lead to reductions in energy use and result in savings associated with recovering and treating lower quantities of wastewater and treating and delivering lower quantities of drinking water. So as long as you're not losing these items, you don't want to lose something you've already paid for. You don't want to do the work twice. Why retreat, water that you've already treated? So in doing that, finding where these leakages are and not losing it is beneficial to the savings. I mean, we all know that it's you don't want to make money and throw it out the window. You got to make sure that you hold on to everything that you've worked for, so you're not losing it all.
And this doesn't have to be an incredibly high cost project either. A lot of water networks are already moving towards smart meters for their clients because that provides the client a notification when they've got a leak in their building so that they're not paying for water they're not using. But now you've got a tracked metered source of water consumption in the network that if you add just a couple more sensors to your main distribution lines, you track water flow through that network. If it doesn't add up to what's being consumed, there's a leak there. You can start targeting those areas for remediation. So it depends on where you're currently at with the automation of your distribution network. Do you have these smart meters in place or not? Is it something you're moving towards? So the cost to implement something like this can vary significantly depending on your existing level of automation in your community. But as more and more communities are moving towards these smart meters, they've got radio controls. They can send signals of their usage as someone drives by. You don't actually have to go out, walk over to the meter and read off the dial what's going on. As more and more of those get implemented, doing this kind of network leakage monitoring gets easier to do. And it can just be a spreadsheet application in your office. You've got your tracked water consumption in the network, any kind of non-revenue water that's used, but you know about, like there's a fire, so they use water from a hydrant. Generally, that's not metered, but you can kind of estimate what that water consumption was. Once you subtract all those off, then you can calculate kind of what your distribution network leakage rate is. And you can start trying to narrow down where in your network those major leaks are at and target those for repairs before it becomes an issue like a water main break or a sinkhole or something like that, that's going to have additional emergency repair costs associated with it.
Well, in doing the distribution network leakage monitoring, you can, you set together some steps to mitigate these issues. You can have a plan. You got to get ready. You got to establish the facility's energy policy and overall energy improvement goals. You got to secure and maintain management commitment, involvement, and visibility. Choose an energy fence line. Establish energy improvement program leadership, and secure and maintain employee and management buy-in. You got to sell it to everybody. Everybody has to be on the same page. You can't have somebody say, hey, it's not using that much power. We're not losing that much water. Everybody has to be on the same page to have the same goals. You have to assess the current energy baseline status. What do we want to save? You have to know what your benchmark is. And then you got to perform an energy audit, as we're talking about today. How do we save this? Identify the activities and operations that consume the most energy or they're the most efficient. Establish an energy vision and priorities for improvement. Identify, evaluate, and prioritize potential energy improvement projects and activities. You also need to identify energy objectives and targets. Establish energy objectives and targets to prioritize, implement, and areas and define performance indicators. So you have to put together a large plan in order to, mitigate these issues in your system. Then you have to do these things. You have to implement energy improvement programs and build management systems to support them. And then you got to get the top management commitment and approval. That's a huge item right there. I know on the wastewater side, management never seems to care what you're doing at the wastewater plant. You're not important. So you have to get them on board so that they know that you need to do something to, help save money in the system. You got to develop the management system operating controls to support the energy improvements and begin implementation once approvals and systems are in place. You have to check, monitor and measure the results of the energy improvement management program. You got to make sure what you've done is doing what your goal is set out to do. You got to review the facility current monitors and measures and track the energy use. Determine what else the facility needs to monitor and measure its priority energy improvement operations. Develop a plan for maintaining and efficiently of energy equipment. Review the facility's progress toward energy targets and take corrective action to make adjustments when the facility is not progressing toward its energy goals. And then monitor, reassess the compliance status. So once again, go through and you got to monitor these things and make sure that you are getting bang for your buck. Make sure you're doing and saving the things that you want to do. Otherwise, you're going to have to change that. And then you have to act on all these items. You got to maintain the energy improvement program. You can't just say we're doing this and then forget about it. You got to continually align your energy goals with the business and operations goals. Apply lessons learned, expand involvement in management and staff, and communicate the success. Communication is the greatest thing I find that in municipalities, you've got to get the people involved as well. Every time you turn around, something costs money and the people are paying for it. So to get them on board to know that you're doing things to, make things better, cleaner water, better delivery, less water breaks, all these different things, the communication is key. If I could do anything, I would be the greatest communicator for all cities out there for, mitigating their issues when it comes to their water and wastewater plants, and hope that you can get the mayors and the city councils involved in these things to make everybody's life a lot easier and safer. There's many ways that we can all be more proactive, I think, and starting at the top is always very helpful. And I will say one more thing about myself is that I'm also a school board president. So I know how a lot of those things work, and I'm always open to hearing the ideas from the people that are actually doing the job. And that way they can get, better funding and better equipment to do the tools or to do the job that they're doing. So they have the tools to be successful. So I feel that that's something very important, is the communication success of all these programs so that people know what they're spending their money on.
All right, before we move on to our next section, we do have one more poll here. When water demand drops, so does the system pressure. Is that true or false? And then for pressure management systems are only effective in networks with high topographic variation. Was that true or false? I saw someone had their hand up in the chat. If you do have a question, please go ahead and put it into either the chat or the Q&A or let us know somewhere we can get that addressed. Okay, give that poll question a few more seconds here. Okay, most people got their answers in. So for both of these, it's false. When water demand drops, usually pressure is going to go up. You don't have water getting drawn out of the system, but your plan is recharging your water towers or repressurizing if you're using pumped pressure. So generally your pressure is going to go up when your demand goes down. And that's what exacerbates leaks. So that is a false statement. And then for pressure management systems, are most effective when you've got high topographic variation. You know, if you've got a low spot, then your water plant's up on a hill. That low spot's going to have really high pressure. So usually we see PRVs in place or some other pressure management system. But that's not the only time these are effective. If you've got a really large municipal district with multiple control zones, pressure management can help even out the pressure across all those control zones and make sure that everyone's got similar pressure requirements, that someone's not drawing down and causing low pressure somewhere else in your network. And so again, high topographic variation is going to give you the most benefit from having pressure management systems, but that's not the only place that it's applicable. There are other times when you can use that. So the last thing we'll dig into are some of the things you can do with SCADA systems.
Sorry, Sean, my other screen went down. Apologize for that. I got too many screens open. We'll wing it here. The SCADA gatherers SCADA gatherers provides control and limited data history only. Growing industry in water management suits can review historic data, filter out unnecessary data, focus on key points, assist in the decision making. So we have, go ahead.
Yeah, so what we're looking at here is, a lot of your SCADA systems, you're going to pull just a little bit of history from, your flow management might store a few months worth of flow history for your review, up to a year sometimes we see. It may also store runtimes and the current speed and pressure output from your pumps. But SCADA systems just store that data. They don't really help you analyze it. Usually that's up to the operator to try to dig through that data and make sense of it. And we know a lot of operators are busy. They don't usually have the time to do that. So there are water management suites that can help with that. You can tack them onto your SCADA system, and they can do things like help you forecast what demand's going to be. So you can optimize your plant for, your daily loads. Maybe you've got regular seasonal events like tourists or those of you that work near university campuses, you've got student loads that swing between fall and winter and the summer. Those have a big impact on your water demand and how your plant needs to operate. A lot of times operators are kind of manually adjusting for those seasonally, but you can have a system that helps do that for you and save you that time. They can optimize energy demand. So for multiple pump systems, they can help pick the optimal pump for the current conditions and optimize that efficiency. Maintaining water quality. We're talking about distribution networks. One of the things to be concerned with there is the age of the water. The longer that water's been sitting in the distribution network, now you've got greater risk of disinfection byproducts from chlorine in there. leaching of chemicals from pipe walls for those of us working on lead and copper lines and haven't replaced those yet. Water turnover, and making sure that that's not too old is going to help ensure that that water is still clean and usable. And so a lot of water networks do periodic flushing of dead end legs and of systems and things to help control that water age. These systems can help monitor and track that kind of flow and consumption in your network and give you an idea of what the water age is so you can better track that. Then you can also optimize chemical dosing. You know, a lot of plants have figured out, I need this dosing rate of fluoride and chloride and the different phosphates, you know, water softening things. You figure out what they need and program that into the little peristaltic pumps that are supplying those chemicals to the network. But if a sudden swing in demand happens, then they've got to go in and change those. SCADA system can help optimize that with some programming logic, but you can kind of get a little bit tighter control with some of the forecasting of demand and things like that, that can better optimize that chemical dosing instead of just, you know, the basic SCADA controls that are offered. And kind of the last point to talk on here is how can you make use of what you've got? You know, even the most basic water plants have flow monitoring. They've got hour meters on their pumps. Maybe you've got timers set up on your backwash system and chemical dosing systems to control those. So how do you optimize that? One of the things you can look at is your monthly operating reports. We've seen a lot of these in doing our assessments with water facilities that are filled out by hand. When you've got the sensors in place, if you automate it a little bit, put in a SCADA control system, that it could populate those reports for you with flow, with run times for pumps and motors. With a little bit more sensor control, it can also populate the chemical dosing that's going on with that system. And so that could save you a significant amount of time just in generating the reports. Now, instead of manually entering all that information, all you got to do is scan through it, review it, make sure that the numbers make sense. You don't have any sensor errors that are throwing off the readings or anything like that. But that can be a significant time savings for you as well by having these reports automatically generated off sensors that are already there in your system anyway for you to fill these out manually. So if that's something that is of interest to you, there are ways to do that and automate those systems. An example here that we're showing on screen is the DreamReport.net is an open source program. You can put the sensors in if you don't have them yet, if you've got the old analog flow meters and things like that, you know, all you got's the paper wheel with your flow rates on it. If you can bring that into a computerized SCADA system, then you can use this DreamReport software, program in what information you want to pull out of that SCADA and populate these reports automatically for you. Jimmy, I don't know if you've got any follow-up or additional comments on using what is already in place.
Do not, other than, you know, just using the SCADA and process instruments to monitor. I mean, I'm such a fan of having process instruments. That way you can see what the demand may be on your SCADA screen and be able to adjust for that. That's I'm a huge fan of having process instruments. You know, that goes for flow and anything you're monitoring. Most of the time I'm monitoring things in wastewater plants, but you know, when you're looking for DO and ORP and pH and things like that, it's always nice to be able to see that on the SCADA screen. And then you can put together a trend and knowing how things are going to run, and motors on VFDs will ramp up and down to meet that need to be the most efficient as, you know, as it goes forward. So anytime you can put some type of process instrument in place and run it back to your SCADA for control, it's I love it. I think it's so efficient and so helpful for the operators. Especially nowadays, you can go ahead and get those and put them on your cell phone as well. So you can see them on a tablet or see it remotely, and that's always a lot of fun as well.
We did have a couple questions come in the chat asking about how long should you store history for like an SQL report or SCADA trending histories. Some of that's going to depend on kind of what your variations you're seeing at your plant. Like, is it fairly stable? Do you have seasonal variations that you need to track? Usually we see back to about a year stored. If you've got the server space, and we'll see multiple years, 2 or 3. But But if you're going to be doing some of this like advanced analysis and data trending, trying to forecast future flows and stuff, you'll want to have a few years of data stored in a historian to get.
I would recommend as much as you can.
Yeah.
Save as much data as possible. If you don't have the capability of storing it, I understand, but otherwise that data is priceless, especially moving forward into the future. If we want to do upgrades and things like that, engineers absolutely love having data to be able to move forward.
Mm-hmm. We had another question about pulling in and collecting data from multiple systems. So the example they gave here were from the lab, manual operator, your MOR reports, the SCADA system, and being able to report them from one common system. If you can find an open source protocol, the Dream Report is one example of that. You can program that to pull from, if you've got a central lab computer that your data is input there, it can pull that data and put it into a report for you. It can pull SCADA histories and stuff that you would normally add to an MOR report. So that is out there. There are a number of different companies that either have open source tools or proprietary protocols that can tie those things together. And a little bit of searching can find multiple options.
And I know there's some data companies out there or people that put together the SCADA systems that can actually put together a program that collects that data at a certain time every day, be it maybe flow or whatever you want to do, and that can spit that out in a report that you can keep with you as well. So it kind of timestamps that information, and so that's also handy. But it is pricey, but it's well worth it if you can afford it.
Okay, we've got our last poll for the day here, and then we'll wrap up our presentation. What common data can be automatically populated into an MOR report? Your flow rates, your pump run times, your system pressures, chemical dosing, or all of the above? I think that's pretty easy once we just went over that for everybody. Any follow-up comments or final notes here, Jimmy, before we start wrapping things up?
Oh, I would just like to thank everybody for listening to me talk. If anybody wants to reach out, and I'm definitely way more versed in wastewater and efficiencies there. So if you got some wastewater guys out there that are wanting to figure out how to run a little bit more efficient, I am more than happy to assist them. And maybe some of the water guys can teach me a few things. That would be great.
Yeah. And we're always planning for future webinars. If something here caught your fancy, or like, hey, I have that at my plant, let us know. We're going to be scheduling future webinars, talking about different topics and stuff. If there's something you want to see covered or something interesting at your own facility you want to make sure other people know about, let us know. We'd be happy to include you in future webinars as well.
I think also Shelby Biggs had her hand raised. I don't know if she would like to speak, but I'm going to let you speak if you'd like to, Shelby. You've had your hand up for a long time. I'll pause for a minute if you want to unmute and ask your question. If not, that's fine. I know that button can get toggled and you're not even sure it got toggled.
It looks like everyone got that poll question. Yes, you can put all of those in your monthly operating report, whatever you need. You just got to find the proper network connections.
Great. Well, I don't see any additional comments in the chat. Sean, anything else before we close out today?
Now, I would say for the operators that are out there working multiple jobs and struggling to find ways to find time to do things, reach out to us. We can help with an assessment. We can help find the funding to put in these automations and controls for you to help improve plant processes and get you the time you need in your day to do everything else that you need to do.
Awesome. Thank you, Sean. And such good information. I agree, Glenn, in the chat there. Thank you so much, Jimmy and Sean, for your presentations today. Again, we will have, this session has been recorded, so I'll send out the recording and the slides as soon as it's available to everybody who joined today. Again, CEUs are coming. I will email out certificates and CEUs course numbers when they are available. Thank you for your patience with that. And we appreciate you taking some time today to join us. If you're curious about funding your energy efficiency projects, please join us next Tuesday at 11 a.m. for that webinar. So thank you. I hope you have a great afternoon. Hope y'all stay warm out there. And I know the snow, at least in Champaign, has started to melt. I hope it's melting where you are too a little bit. And have a great rest of your week. We'll talk to you soon. Take care. Thank you. Bye-bye.
Thanks, everyone. Appreciate you.